Okay, I guess I don't have everything written here, but it's called factoring special products. So I'm going to start by giving an example where we have to multiply something. So I'll have an expression of this form: a plus b times a minus b. I want to see what's going to be that equal to. But one of the methods is to take the first term and multiply it by everything inside the second parenthesis. So it means that I have to do a times a. It gives me a squared. Then I have to do a times negative b. That's minus a b. And then I repeat that. So I move to the next term and I repeat that. So now it's b that I have to multiply by everything inside the second parenthesis. So b times a is positive, well, I'll write ba, and then b times negative b, it's minus b squared. So what can we see here? Here's the question. What do you think about those two terms? Are they the same or different? ab and ba? Different. They look different. They definitely look different, right? Because it's ab, and I'm kind of ignoring signs right now. ab versus ba. But remember what, well, remember that what was said about multiplication operation. And by the way, AB, it means that, well, it's a times B, right? Or BA times, it's same as B. So BA, it's same as B times A, right? We just glue them together and don't bother writing this multiplication symbol. But we said that when we multiply, it doesn't matter in which order we multiply, right? BA, it's same as AB. I can easily switch them around or change the order and I'll get exactly the same result. So they are, after all, they're all the same. Well, AB is same as BA, but since they have opposite signs, it means that we can cancel them, or we should cancel them, right? They cancel each other out because they are the same. So negative AB and then positive BA, they just cancel each other out. And the point is that we're going to be left with only a squared minus b squared. So the point here is that we multiplied expressions that looked almost the same. The only difference was that plus in one and then minus in another. And we multiplied kind of regular way, but then two middle terms, they got canceled. And we're only left with a squared and minus b squared. And what we just did, once again, we multiplied. So we did multiplication, right, this way. Multiply. But remember, factoring is the reverse operation of multiplication. And that was another question on the quiz. So the reverse operation of, well, the question was about factoring. But anyway, they are reverses of each other. Multiply that way, going backwards is the factoring. And if this example made some sense, then this is now what we can write down. Well, for factoring, we're going to start actually on the right-hand side. That's where we're going to start to factor. So we start on the right, and we're going to end up with what's on the left. And that actually creates a formula. So that's why we call it special products. So whenever we have, I'm going to write it one more time. Whenever we have expression that has this form, a squared minus b squared, and what kind of form is that? Well, something squared minus something else squared. Then we can right away write down the result, and that result will be, well, put each thing that's being squared inside the parenthesis. And then one parenthesis will have plus, and one will have minus. And again, I can switch them. Order is not important. I can put minus in the first one and plus in the second one. But that creates a formula. And I'm going to give you a few examples, and after you see them, it will make total sense. So, for example, if I have, let's say, x squared minus 5 squared, and I'll say, well, factor that. Would you agree that x squared minus 5 squared has same structure as a squared minus b squared? Do they look alike? Right, and then that means that we can right away say what the factored form is. So I'm going to set up parentheses, and what should I put inside them? What do you think?
X and X, 5, 5.
Yeah, x, 5, 5, and then plus in one, minus another, or minus in first, plus in the second. So basically it's x plus 5 times x minus 5, and you're done. So if you notice that pattern, something squared minus something squared. Factoring is like, 1 second step. So let's try to get, well, the only tricky part will be that, well, for this first example, let me call it example A. Things were like very obvious, x squared and then 5 squared, okay, we're done. But most of the time things will not be that much obvious, but let me show you what I mean. So for example, if I have a squared minus 81. So for this formula to work, again, I have to have squares. Both terms should be squares of something. Obviously, the first one is the square, right? I have a squared. But 81, I mean, there's no square written. But can you think how we can fix this? Do you see, like, there's something hiding there in 81? Can you think of it?
9 times 9.
That's right. 81 is 9 times 9, which means that we can write it as 9 squared, right? So I can rewrite this expression as a squared minus 9 squared. And now it looks exactly like that pattern for the formula. So it means that I can right away say that it factors like this: a plus 9, a minus 9. So if you're trying to use this formula, you want to obtain squares in both places, and sometimes you just have to rewrite a number as square of something. Let's try one more example. How about 49x squared minus 100? Does this expression qualifies for this formula? By the way, this formula is called difference of squares. Difference for the minus sign. So difference for the minus sign. Okay, what's that?
So wouldn't it be 7x? It's the first one.
That's right. Difference of squares. You're right. Yes. Go back. Let's go back to one. So we want to have squares for each. So we want to write like square of something minus square of something. I'm gonna start with maybe like with an easier part. 100. 100 is the same as 10 squared.
10 squared.
That's right. 10 times 10 is 100. So minus 100. And then what is being squared in the first place? Well, x is being squared, but next to it is a number. Everything has to be a square. So that number we write as 7 squared. And in fact, I can write this whole term as 7x. And then this whole thing is squared. Because if I square 7x, or if I, so that's what I think about it. That's how I think about it. If I do 7x times 7x, well, that's going to be 49x squared, right? So now I can see squares, and as soon as I can see squares and the minus sign here, it means that I'm ready to write down the answer. 7x plus 10 times 7x minus 10, or you can switch the signs, or the order of signs. So that's the formula. And then the last example for this, kind of like subtopic is this one. X squared plus 36. So what can you say about this expression? I have x squared, so it's like a squared. I have 36, but I can always rewrite it as 6 squared, right? So it looks like I have squares, but what is not quite the same? Like one part is not the same. Can you guys catch?
The signs.
The sign, right? So see how it's plus in between? And our formula has minus. Well, because with plus, we won't be able to factor it. And you can even, if you're like, well, why not? I mean, it was so easy with minus. You can even try, because what options we have. So I'm just saying that, well, we're not going to be able to factor, so I'm going to say is prime. But you don't have to believe me. Actually, you actually want to question everything I say out loud and in your mind, and that is like where we're like, okay, let's try. I mean, let's kind of confirm, because if we can factor, what would be like the good options. We're not going to check with plus and minus, right? If I put x here and 6, x and 6, I'm not going to use plus and minus because I know when I multiply, I'll get what I have in that formula. So I'll have x squared minus 36. Well, if I'm not going to use plus and minus, maybe I'll use 2 pluses like that, right? I mean, that's probably like the best guess. Why this would not work? Well, x times x is x squared. X times 6 is 6x. And then I have the other 2. So it's another 6x plus 36. See the problem? So we do have x squared, we do have 36, but the problem is that those 2 will not cancel, right? So we'll end up with x squared plus 12x plus 36. So we're not getting this original expression. So it means that this is not going to be the way to factor. Now it does not work with pluses. With both pluses, will it work with both minuses? So if I have x minus 6 times x minus 6, maybe that will work. Maybe like those minuses will make things to cancel. Well, if I factor it, it's going to be x squared minus 6x, and then those 2 minus 6x plus 36. Again, I do have x squared, and then I have plus 36, but those 2 middle ones will not go away. It's going to be x squared minus 12x plus 36. So again, that would not be the way to factor. And I mean, it would be silly to think about any other options, right? Except x and 6 inside those parentheses. So anyway, the long story short, we do have only one formula. That's a good news. Only one formula for when we have squares, and that formula only with the minus. So there is no formula for plus. So I'll say a squared plus b
So
squared.
automatically, when you see a plus sign, it is prime.
Exactly. And that makes questions like that super easy because you see plus, you're like, okay, I know it's prime. So is prime no formula? Automatically. That's right. And then I'll, like, for the last portion of this factoring special products topic, I'll just show you, well, there will be 2 more formulas, and those formulas will be with cubes. I'm not gonna kind of torture you by trying to figure them out. I'll just give them to you. You have them somewhere in your notes, like on the side, like box, so you can always refer to them. Since we're doing things online, you don't even have to memorize them. Like usually, like in the class, I would, have students to memorize them or put them on the note card. Anyway, but for you, it's just guys just having the formula somewhere in your notes and just knowing how to use it. But basically, so, and then we'll kind of put this all together so you'll see like the big picture. But there are 2 formulas for cubes. So we have, let me use maybe a lowercase a and b. That's how we have it. I have it on the handout. So if you have something cubed minus something else cubed. So it's very similar to what we just saw, but it used to be squares, but now it's cubes, 3rd powers. Then this is how you're gonna factor it. You'll have short parentheses and then you have long parentheses. The short parentheses will have just a and just b with the same sign as the original expression, so with minus, a minus b. And the second expression, the longer one, will have 3 terms. It will have 3 parts. It will have a squared and then b squared on each end. And in the middle, it's going to be just their product, so a times b. And the signs that you put here are plus and plus. So, I mean, at first it's like, oh, that's a lot. Like, how do you remember that? Well, I mean, there's a way to remember it by, even though you don't need it. It's just, I don't know. It's not good to talk about it. Again, the way I remember it's like long parenthesis times short parenthesis. No, I'm sorry. It's short first and then long parenthesis, right? And how do you remember the signs? Well, there is a trick to remember the signs, and it's called SOAP. Like, I mean, guess what? I just realized that with everything that's going on, like soap is like the theme, right? Washing hands using soap is the theme. So it's going to be easy to remember. So if I write SOAP like that, what it means is SOAP stands for same, meaning that it's always going to be the same sign as here. O stands for opposite. Opposite. Well, in the original expression, it's minus. Here it's plus, so opposite, right? And AP stands for always positive. AP, always positive. That's how you can remember the signs. Now, what we'll do, I'll give you, well, I'll start writing the second formula. That one will be with plus. So for cubes, we have both, with plus and with minus. Remember, for squares, it's only minus. For cubes, it's both. The formula for plus and minus. And I want you to write it kind of like yourself, or help me to write it. I'm just going to tell you that A's and B's will be exactly the same and on the same spots. It's just the signs will be different. But to figure out signs, you use this SOAP trick. So what do you think I should put inside the first expression? Okay, Erica, yeah, I could read your lips. A plus B, that's right. But yeah, no, I'm at mute you, so I don't think I can read anything more complicated than A plus B. So what do you think is the second expression? Again, it's going to have same structure, just signs will have to follow the SOAP pattern. So what do you think I should write?
A squared minus?
A squared minus AB, and then?
Always positive.
Always positive, so it's plus B squared. That's right. That's how the second formula goes. Same sign, so as in the original expression. O for opposite, always positive. Let's do maybe like, I don't know, 2 examples to illustrate how those formulas work. So it makes sense. So let's try example A. So let's do m to the 3rd power plus 125, like that. Do I have expression that qualifies for one of those 2 formulas, or both those 2 formulas? Or for those 2 formulas, I have to have cubes in both spots. I do have m cubed, but do I have another cube, like 125?
5 cubed.
5 cubed, that's right. And you really want to rewrite like that. Don't skip the step. So write m cubed plus 5 cubed. So they're like in front of you. It's easier than to follow. Okay, then now I can set up the short parentheses and the long parentheses, or the parentheses for the short expression and the long expression. So what should we put in the short one? Oh, and by the way, it's going to be this second, right? The second formula, because it's with the one with plus. Amy?
M plus 5?
M plus 5, that's right. So in the first one, you just put those things, well, variable and a number, but with no cubes, like just them, right? Cover up cubes and you'll see what goes into the first one. M plus 5, okay, perfect. What's the second one? So what is this part for us?
M squared.
M squared.
And 5 to the second.
M times, well, so 8 plus B.
Oh, AB.
Again, this is like A and this is like B. So just pretty much multiplying them together. So M times 5, right? But it's same as 5M. I can switch it so it's a little bit more convenient to say 5M. Oh, and then of course it's minus, right? In that formula, 5M. And now what is B squared? Right, so it's the second one squared. So I write plus 5 squared. But you want to rewrite this expression, and since this is something you can calculate, you go ahead and calculate. So you know what 5 squared is, right? So the final answer will be m plus 5 times m squared minus 5m plus 25, like that. So that's how you factor. It's called sum of cubes. Sum for this plus, cubes for having both terms as cubes of something. Like that. And now the last example here. Let's try 27x cubed minus y cubed. Like that. Do we have a pattern for the difference of cubes? Do we have cubes everywhere?
Yes.
We do. So that 27, I mean, numbers also should be cubes or squares for our first formula, but everything should be written as cube of something, so, or third power of something. So what is 27?
3 cubed.
3 cubed. That's right. So what I'll do for the first term, I'm going to write like this: 3x to the third power. So the whole thing is to the third power. And that's how the first term is, minus y cubed. And now I can see like the first thing cubed, that's the second thing cubed. It's like a cubed minus b cubed. I covered up the formula, but let's see if you remember the pattern. I mean, you have it in your notes, but kind of check yourself. See if you can do it without maybe looking in your notes. So what should we put inside the first one?
How is that 3x instead of 9x?
It's going to be 3x. Oh, why is it 3x instead of 9x? Because think this way. So we're using cube, right? We have to, cube means that we have to multiply 3 times, right? So it's 3 times 3 times 3. So when I do 3 times 3 times 3, I get 27. But if I try with 9, then it's going to be, I can only think what it is, but it's going to be like a big number, right? 9 times 9 is 81, and then 81 times 9, whatever it is. So yeah, that's a good question. So with cubes especially, be careful. And I always like double check myself. I write number, and then in my head or on the paper, I just multiply it by itself 3 times. If I go back to the original number, then I'm good. If I'm getting something different, then I have to think a little bit more. Does that make sense why it's 3? So cube means it does.
Why does it have a parentheses around it?
Well, good question. So it's one of the ways to write it. The other way I could write like this: 3 cubed x cubed, right? So 3 cubed is 27. Well, and then x cubed I had there to start with. Okay, here's another way to think about it. So if I take 3x, and since it's raised to the third power, well, I'm saying that it should be to the third power. If I multiply it by itself 3 times, again, I'll get 3 times 3 times 3, that's 27. And then x times x times x, it's x cubed. It's just kind of like an alternative way to write it. And it's when I put inside the parentheses number and the variable, it's a little bit more clear for me what exactly is being raised to the third power and like what my first term is, like what is my a. So 3x, so it's number and the variable there together this time. So that makes like one term. Yeah, and for this reason, we're gonna have 3x here, 3x minus y. So remember, sign is the same. I'll say s, for the same sign. So it's like cover up those cubes and you'll see what to put inside the first expression. Now for the second expression, we have to put squares of each of those things on each end. So it's, again, I'll keep using parentheses. So it's 3x squared on this end, and then y squared on the second, on the other end, right? And then what's right in the middle? Right in the middle, we have the product of 3x and y. So it's basically 3x, y. Now let's figure out the signs. So soap. Now, first sign is opposite of the original sign, so it has to be plus. And the second one is always positive, so plus and plus. Well, let me write this. So, oh, well, I'll have to rewrite it anyway because this is the reason, because if I can simplify something, and that's the part I can simplify, I can raise 3x to the second power, it's going to be kind of like another reason for me to rewrite this expression, the answer. So 3x minus y. And then instead of 3x to the second power, I'll square that. So it's 3x times 3x. That's going to give me 9x squared plus 3xy plus y squared, like that. So,
how do you get the 3xy?
3xy. Okay, so I got 3xy. Where am I? Oh, right here. I got 3xy, so this part, right? The part that's in the middle, so if I go back to the formula, remember in the middle, right here, we have a times b. So it's like taking this term and multiplying it by this term, multiplying them together, a and b. So in my case, it's taking 3x and multiplying by y. So if I multiply them together, I get 3xy
Oh, okay, I see.
right in the middle. So it's always their product in the middle.